All right, this is week 2 of our daily FRQs. This should be the one you worked on yesterday on Monday. This is a 2015 exam. We're finishing up 6 and 7 today, and then you should be working on the 2016 exam 15 minutes today, and we'll go over that problem tomorrow. This is one of the short ones. You only got 2 parts, A and B. Likely that they're both 2 points as we go through this thing. So 4 total points here. They give us 4 different compounds. They're all ionic compounds. They give us melting points of these things, and then a student learns that the ionic compounds have significant covalent character when a cation has polarizing effect on a large anion. I don't know what that means. It's a lot of words. It says, as a result, the student hypothesizes, that's always good, that salts composed of small cations and large anions should have relatively low melting points. It says, select 2 compounds from the table, explain how that supports the student's hypothesis. There's options. There's lots of options here, and so I'm gonna post the college. I'll put the College Board answers right up here in a second. I found the one that was small cation and large anion. So lithium is at the top of the alkali metals. It's one of the smaller radii for the alkali metals, and then iodide is a big anion. So we have a small cation and a large anion and a low melting point. So I chose lithium iodide in part A. I chose lithium iodide and wrote it has a small cation and large anion and a low melting point. Compared to, it asks you to compare 2 of them. So select 2 compounds and explain how that supports your hypothesis. And so compared to, and so I looked for the opposite one. So I looked for the one that now has a bigger cation and a smaller anion, hoping that it has a high melting point. If we look here, sodium is bigger than lithium, fluorine is much smaller than iodine, and there's a much bigger melting point. So I put lithium iodide has small cation, large anion, and low melting point compared to sodium fluoride that has a large cation and small anion and really high melting point. That's how I answered the question. The College Board, so you got a point for having 2 compounds that made sense, and then the explanations behind those. Here are the College Board's answers. There were 3 different combinations you could have used. Lithium iodide and potassium iodide, showing that bigger cation in potassium iodide created a bigger melting point. That was fine. You could have chose lithium iodide and lithium fluoride, showing that the smaller anion of fluoride causes a higher melting point. Or the ones I went with, the lithium iodide and sodium fluoride. So any 3 of those would have worked. You can pause and look at their explanations there. 1 point for choosing an appropriate pair, and then 1 point for an explanation that supports that hypothesis. That's it on A. And then part B says identify a compound from the table that can be dissolved in water to produce a basic solution. These are all salts, and so we just got done looking at acid and bases last week and acidic and basic salts, hopefully. This says write the net ionic equation for reaction that causes a solution to be basic. When I look at these and I look at where they came from when you mixed them, mixed acids and base together, lithium iodide came from lithium hydroxide and hydroiodic acid. Strong or weak base, that's a strong base. Strong or weak acid, that's a strong acid. And so that salt, that lithium iodide that forms, is a neutral salt because those are both strong. Potassium hydroxide, same thing in the second one. Potassium hydroxide, strong base. Hydroiodic acid, strong acid. And so that one's also going to be a neutral salt. You had to choose either lithium fluoride or sodium fluoride. I'll write both of the equations here for us. If we took lithium fluoride and we dissolved it in water, our products are lithium hydroxide, strong base, and hydrofluoric acid, weak acid. And so we have a strong base there and a weak acid there. And so that salt is going to be, or that salt in solution will be basic. Our solution is going to be a base as a result, which is what they want. They want the net ionic equation. I will tell you, sometimes it's easier writing this thing, and it's not something that people are like, ooh, that looks really great. I like that form. But that kind of shows you how it looks like a double replacement reaction, this acid base, where the lithium's now with hydroxide and hydrogen's now with fluoride. So it helps you look at it that way, that's fine. We need a spectator ion. What's our spectator ion here? This lithium is in solution here as lithium fluoride. It's in solution here as lithium hydroxide. So net ionic equation wise, we have fluoride ions reacting with water to produce hydroxide ions and hydrofluoric acid. The lithium hydroxide or sodium hydroxide, either one of those, is strong, and so it's going to be in solution on both sides. So either way, whether you chose sodium fluoride or lithium fluoride, you have the same exact net ionic equation as a result. That hydrofluoric acid does not break apart because it's a weak acid. It doesn't dissociate very much. And so that guy, you got 1 point for choosing one of the correct compounds. So the lithium fluoride or sodium fluoride. And then you got 1 point for writing the balanced net ionic equation. Is this guy already balanced? The answer is yes. One of those ways you can double check is charges on the left equal to the overall charge on the right. That's a good indicator that it's balanced. And we got the number of atoms equivalent on both sides. That's 2015 number 6. Later.